Hi guys, so quick one for you. This is the processor board out of that Sony DVS7000. I figured that, as mentioned previously, Dave Jones has done some tear down on some of this and looked at the boards, but I thought would look at it in a little bit more detail in the individual boards and try and work out exactly what's going on here. So this is from the desk itself. The desk has unfortunately been completely torn apart. There was never a full teardown video on it. It just took up too much space and it was going to take too long to do the teardown. I couldn't work out how to get that much electronics on my bench and be able to film it. So we'll have a look at this processor board because there's various little things going on, and I know that this will interest some people. So we'll start up at the top with the processor. So let's just move you in here and make sure that is in focus. So any of you that work on vintage electronics know that that is screwed. Before we go any further, that's one of the lithium timekeepers. I believe this one might be of the type where the battery is rewirable underneath, but obviously if this were a piece of vintage electronics I was thinking of firing up and using, then we would be slightly concerned about this. There's a lot of programmable logic in this, which we'll see, but I've got a good idea of what's doing what. So we'll look at this daughter board quickly first, then we can get it out of the way. So we know that these are microcontrollers of some kind, and these are FIFOs. My guess is, and a lot of this is educated guesswork, these are all involved in talking to the displays. These use the HP 4-digit dot matrix displays, and there are an awful lot of them, and this pattern is repeated in several places. So although we've not got a particularly fast processor here, we're using a lot of acceleration to deal with, or a lot of hardware acceleration to deal with talking to probably the best part of nearly 300 buttons, switches, joysticks, and another 100 odd 200 displays. So that's a lot of load even for the processor that's in here to be dealing with. So I believe this is some kind of coprocessor mechanism for that. The FIFOs would allow the processor to write the data that needs to go out to them, and then the micros would then take care of getting this data out. This board appears to be incredibly self-contained. It is really not a lot to it. Just two FIFOs, two micros, and a bit of glue logic for each one. So these are absolutely symmetrical. The glue logic there is line drivers and a bit of 7/4 series logic. So it looks like we've got 4 control lines leaving each chip. So they are probably our control lines for that go up to the board. There's nothing else there. Whatever those lines are, they come directly from the micro. My guess is this would be the processor address bus, or this is literally selected, presented with an address, and then the data written into the FIFOs. These could be useful, especially if you were making your own graphics type card. I mean, if you could work out how to program those chips, assuming they're not one-time programmable, that could be a useful little board in its own right. Underneath we have the same arrangement. So we have the same FIFOs, a different packaged version of the same micro. We've got these Fujitsu chips there, which I will identify and put on the screen there to say what they are. We have EEPROMs. There are lots of EEPROMs. I'm pretty sure they're EEPROMs, but again we'll check the number on them. We have some very fast SRAM up here, and I say that appears to be more or less a copy of what was underneath. So the interesting bit, and the bit we're interested in most, is up here. So we have a 68030 RP40C processor, so that's a Motorola 68030. We have another Altera chip there, which is almost certainly going to be glue logic for the bus. We have our timekeeper, and we have what I'm guessing, given that it's got boot 263 written on it, is our boot ROM and OS. There appears to be 2 distinct buses on this board, so there is all sorts of weird hardware acceleration going on, and we have possibly another processor hidden in here somewhere as well. a lot of places on the board, such as up here. If I zoom you in a bit more, you'll see we have RS232 main and RS232 sub up there, and that's not the only place we've got that. So where are we? There, it appears somewhere else. So up here on the very corner again, you've got main abort, sub abort, you've got a master reset, halt and run. So this probably started life as a VME based single board computer, which has then been changed by Sony into this embedded version. We've got a number of test points here, which are processor signals. So the ACK, halt, DS ACK and address select logic is obviously accessible there for testing. We've got some more there. CK40M 40 megahertz clock. I've never actually noticed those before now. We've got some more going on down here, and as with a lot of this board, there is an awful lot of Sony chippery that's just mystery boxes. Over here we quite obviously have system RAM, system ROM, so we've got flash, and then we've got, I believe this is SRAM again. I will again check and put the part numbers up there or down there or wherever. And then a lot of glue logic here. They are 74FCT16245s. So I would guess bus transceivers or bus isolators. And then we get to this side, and there goes my phone. So we have speaker. These connectors here, there are quite a few of them, go off to the individual switchboards. I can't lay my hand on one at the moment, but these carry various data, select logic and everything to drive the buttons, the LEDs for the buttons and the dot matrix displays, and some of them do other things. So there is one here marked joystick. These two here interface with a panel that contains a joystick and a trackball, so no idea how they're handling that. These are completely serial driven by some kind of SIO type setup using discrete logic, Jelly Bean logic, and somehow they're doing analog and all sorts of stuff over there. We're going to reverse engineer those boards because I've got a panel here which weighs a ton. I'll zoom you out. So each one of these buttons has controllable RGB, orange and green LEDs, as do these, and there are bicolour dot matrix displays above each button. Quite a useful bit of kit, and I've got an idea to use this for it, but we need to reverse engineer the protocol. I've got to the point where I can talk to some stuff on these boards, but not completely. So I'll like to zoom back in again. So we have another EEPROM here which is marked sub. Now this makes me think that we have another CPU in here. My guess for that would potentially be one of these big programmable logic devices. We have more dual port RAM in here. There's nothing that really points me as to what the subprocessor would be. It's not clearly marked, but it's obviously in one of these PLDs somewhere, possibly that one maybe. But again, there are duplicated blocks here, so if I move you over a bit, you'll see that we appear to have the large PLD, the smaller PLD, the two FIFOs, and then we've got the same thing, FIFO, smaller PLD, larger PLD. And we've got another ROM here, but I know what this one's up to. We'll get to that in a minute. We have an unknown NEC chip there. I believe that might be a floppy drive controller. We've got a connector for a floppy drive up here, so that could be an FTC. What else have we got? We've got a EEPROM marked font here. We have another device down here, which I believe the HD63 DVS7000F is actually the display controller, and then we have one of these connectors. I believe it's possibly I believe it might possibly be this one here. It goes off to the display. There is a sorry, my brain stopped working. There is a 320 by 240 amber plasma display, which I'd love to get working. But yeah, you've got those two together. I'm sure that's a graphics controller. If not, then I would say that PLD is probably going to be our graphics controller there. But that's all there is to it. It's quite a complicated little board. It wouldn't have been a cheap board as well. The quality is really good. In terms of things we could possibly reuse from this, certainly I will be taking these EPROMs off and wiping them. The timekeeper will be toast without a doubt. You might get lucky because this has been in constant use for pretty much since it was new at the BBC. The battery may be okay, but I'm not sure it would be worth taking the risk on it. The processor can come out because that is used in other places, and potentially it is an upgrade for machines that we have. We could lift the FIFOs off, they would be useful. But yeah, there's not really a lot on here that I would say would be directly useful to us. As a hobbyist, there's probably even less. But I think the biggest things on here that we would find homes for would be the EPROMs and the 6830. Anyway, quick one for you. Hope you enjoyed. Take care. Bye.